The objective for this video is to learn how to use the TI graphing calculator to conduct a chi-square test for goodness of fit using the p-value method. In a previous video, we learned how to conduct a chi-square test for goodness of fit using the critical and test value method. In that video, we constructed a table that contained the expected and observed values for the outcome of an election. Our decision was to reject the null hypothesis. Using the p-value method, we will compare the p-value and alpha to make our decision. We will use the TI graphing calculator to find the p-value. We will begin by entering the observed and expected values into lists. So we will press Stat and then 1. It is important to remember which list contains the observed values and which list contains the expected values. We have entered the observed values into list 1 and the expected values into list 2. Now press Stat, cursor over to Tests, and then cursor down to chi-square GOF, or goodness of fit test. Older models of the TI graphing calculator are not pre-programmed with this particular function. Press Enter. Recall that we entered the observed values into list 1 and the expected values into list 2. The number of degrees of freedom is 1 less than the number of categories. We have 3 categories, so the number of degrees of freedom is 2. Cursor down to Calculate and press Enter. We find our p-value to be 0.0066 when we round to 4 decimal places. So the p-value is equal to 0.0066, and alpha for this problem is 0.05. Since the p-value is less than alpha, our decision to reject the null hypothesis is consistent with our decision when we conducted the same test using the critical value and test value method. So again, the evidence led us to our conclusion that the party proportions for this particular election vary from the registration proportions. In this video, we learned how to use the TI graphing calculator to conduct a chi-square test for goodness of fit using the p-value method.